On the morning of July 19, 2024, if you were trying to catch a flight anywhere in the world, something was deeply wrong. Departure boards were frozen or blue. Check-in counters had reverted to handwritten boarding passes. At Hartsfield-Jackson, Atlanta, passengers slept on the floor. Delta Airlines alone would cancel more than 7,000 flights over the following days. If you were in a British hospital, your surgery was probably being postponed. The NHS's GP booking system was offline. Pharmacies could not dispense prescriptions. Emergency call centers in Alaska and Arizona and Ohio had to route 911 through manual channels. If you worked at the London Stock Exchange, your news feeds were gone. If you worked at a bank, your tellers were staring at blue screens. Payment terminals at McDonald's across Japan and the UK were dead. Sky News went off the air. In 1,000 different places, at roughly the same time, one thing was happening on Windows computers everywhere. The blue screen of death. Repeating. Endlessly. Every time the machine tried to boot, it would crash before it even reached the login screen. And the cause was a company most of the affected people had never heard of, CrowdStrike. A cybersecurity firm, based in Austin, Texas, that protects more than half of the Fortune 500 from cyberattacks. CrowdStrike's flagship product is called Falcon. And Falcon is what is known as an endpoint detection and response agent, EDR for short. It is software that sits on every laptop, every server, every Windows workstation inside a company and watches everything. Every process started. Every network connection opened. Every file read. Every registry change. It is the immune system of the modern enterprise. And to do its job, Falcon does something extremely powerful and extremely dangerous. It runs in the Windows kernel. Not in user space, where a normal program lives, but in ring 0, the deepest, most privileged level of the operating system. The same level as Windows itself. This is deliberate. To detect sophisticated malware, Falcon needs to see everything that malware could see. It needs to intercept system calls before malware can hide them. To do that, it must live where malware lives, inside the kernel. But there is a rule about kernel code, and every systems programmer knows it. If a program crashes in user space, the operating system kills that program and keeps running. If code crashes inside the kernel, the entire computer dies. There is no safety net. The kernel is the safety net. To keep up with new cyber threats, CrowdStrike pushed updates to Falcon continuously. Most of these were not full software updates that needed testing and signing. They were what CrowdStrike called rapid response content, small configuration files that told the already installed Falcon driver what to watch for. New malware patterns. New behaviors to flag. New kinds of attacks to detect. These content files were pushed dozens of times a day, to millions of machines, without anyone inside a customer's company having to approve each one. That was the point. If a new zero-day attack appeared at 9 in the morning, CrowdStrike wanted to update their detection rules by 9:15. On July 19, 2024, at 4 hours, 9 minutes, and 0 seconds UTC, a completely ordinary Friday morning, CrowdStrike pushed channel file 291. It was 40 kilobytes in size. It was intended to detect a new kind of attack using Windows named pipes. Inside channel file 291 were instructions telling the Falcon driver to inspect 21 specific fields of data whenever a named pipe operation happened. 21 fields. But the driver, as it had been compiled and shipped months before, had only been built to access 20 of them. When Falcon tried to read the 21st field, it reached into memory that was not there. An out-of-bounds read. In user space, this is a crashed app. In the kernel, this is a kernel panic. The driver crashed. And because the driver was a boot start driver, loaded before Windows itself finished booting, Windows crashed with it. Before login. Before the network. Before anything. And then the machine rebooted. And because the file that caused the crash was still on disk, the driver crashed again. And the machine rebooted again. An infinite loop. 8.5 million times, simultaneously, around the world. Microsoft would later put the number at 8.5 million Windows devices, roughly 1% of all Windows machines on Earth. 1% does not sound like much. But CrowdStrike's customers were not random consumers. They were airlines, hospitals, banks, governments, broadcasters. The 1% that actually runs the world. Delta Airlines was the most publicly catastrophic casualty. More than 7,000 flight cancellations. 1.3 million passengers stranded. Delta would later claim damages of $500 million and file a lawsuit against CrowdStrike that is still pending as of this recording. In the UK, the NHS's appointment system went down just as the Friday surgery schedules were starting. In Alaska, the state troopers lost their dispatch system. In parts of Arizona and Oregon, 911 calls had to be routed through neighboring counties. At airport after airport, check-in reverted to pen and paper. Staff wrote boarding passes by hand for hours. Photos circulated of printed Excel spreadsheets pinned to walls where real-time flight boards should have been. And the fix was grotesquely simple and grotesquely difficult. The driver file had to be physically deleted from the disk. But because the machines would not stay booted long enough for administrators to push a fix remotely, somebody had to walk up to each affected machine, boot it into safe mode, navigate to a specific folder, and delete one file. By hand. 8.5 million times. In many environments, that required a person physically present at every machine. Some companies finished the recovery in hours. Some took days. Some, who used disk encryption and had stored the encryption keys on the very same affected machines, found themselves in a chicken-and-egg loop that required restoring from backups. 5 days after the outage, CrowdStrike published their preliminary post-incident review. And the technical details, when they came out, turned the story from a disaster into a case study. Rapid response content updates were validated by a piece of software CrowdStrike called the Content Validator. Its job was to check that any new content file would not crash the driver. And on July 19, the Content Validator had a bug of its own. A bug that allowed channel file 291 to pass validation, despite containing a field the driver could not read. But that was not the only failure. Because even if a bad file slips past validation, there is a standard defense in every modern deployment pipeline. A staggered rollout. You push the change to 1% of machines first. Then 5%. Then 25%. You watch for crashes. If anything breaks, you stop. CrowdStrike did not do that. For rapid response content, they pushed to every Falcon-protected Windows machine on Earth, all at once. Because speed was the product. Because slow detection meant missed attacks. Because the whole value proposition of Falcon was that when a new threat appeared, your protection updated in minutes, not hours. In the root cause analysis, CrowdStrike identified not one failure but a chain of 6. The validator bug. The missing integration test between content and driver. The lack of staggered rollout. The lack of runtime bounds checking inside the driver itself. The lack of machine-level safeties that could have prevented infinite boot loops. The lack of the specific template types test coverage. Each one, individually, would have stopped the disaster. All 6 failed at once. Microsoft would respond to the incident with a blog post questioning whether security vendors should have this much kernel access in the first place. CrowdStrike, and every other EDR vendor, argued that without kernel access they simply could not detect advanced attacks. The European Union's antitrust rules had actually required Microsoft to give third parties the same kernel access Microsoft itself enjoyed. That rule was now under review. CrowdStrike stock fell more than 40% in the following weeks. The company agreed to customer compensation packages. George Kurtz, CrowdStrike CEO, testified before the United States Congress in September of 2024 about the incident. Class action lawsuits were filed. The Delta suit alone continues. Every software engineer who has ever pushed a breaking change to production knows a small version of what happened that morning. The commit that looked right. The test that passed. The deploy that went smoothly. And then the alerts. And then the rollback. And the private horror of a monitor full of red. The difference between an average engineering mistake and the CrowdStrike disaster is that most software, when it breaks something that can be turned off remotely. Most software is not inside the Windows kernel of the machines running the airline, the hospital, the 911 dispatch center, and the Tokyo subway card reader, simultaneously. Most software is not pushed to 8.5 million computers at exactly the same instant, without a human approval gate, because speed is the feature. The deeper lesson of CrowdStrike July 2024 is about trust. Every company running Falcon had, without really thinking about it, handed CrowdStrike the authority to reach into their kernel dozens of times a day, from Austin, Texas, with no approval step. In exchange, they got better security. Until the day they didn't. After July 19, CrowdStrike rebuilt its entire content pipeline. Staggered rollouts for rapid response content. Customer-side controls to let IT administrators choose which rings of deployment they wanted to be in. Improved bounds checking in the driver. Better integration testing. External auditing of the fixes. Microsoft began a multi-year effort to move security vendors out of the kernel and into a new, safer, user mode detection framework. That work is still ongoing. The change is technically hard. Politically, given the EU rules, it is harder. Today, if you fly Delta, the computers work. If you walk into a British hospital, the booking system is up. If you dial 911 in Arizona, the dispatcher answers. The outage ended. Life returned to normal within days, for most people. But if you are inside the industry, if you have ever deployed software to production, there is a thought that has never quite gone away since that Friday morning. 8.5 million machines went down because one company, that most of the affected users did not know existed, pushed a 40 kilobyte file, and nobody had built the safety net that should have caught it. The world ran. And then, briefly, it stopped. And the distance between those two states turned out to be the size of a bad pointer to reference. Somewhere, right now, inside a company you depend on, another piece of software you have never heard of is sitting in the kernel of every machine that makes the company run. It updates automatically. You will not read the release notes. It is, statistically, fine. Until it is not. Thanks for watching.